Let me. Okay, I think I might have just started the recording. Okay, so you might not get everything that I just said in the recording this week. I don't know why it wasn't recording. That is. Okay, sorry about that. So the recording will probably start around here for this week. I haven't gone into any of the tools yet, so I feel like that's maybe okay. I'll repeat this part though. So the data that you're going to be using for this week is the same data sheet that you used last week. It's just down here in this other little tab right here, temperature data. And this data is all of the data that was found from the Google form we asked you guys to fill out. We asked you to take the temperatures of 3 different people and record the temperature, the unit you gave the temperature in, how the temperature was taken, gender of the person having their temperature taken, and age. So if you guys completed this, your data is somewhere on this sheet. Not sure if you would be able to tell your data apart from everyone else's, but it is here somewhere. And if we look at this data, we can see that it's all kind of disorganized in some ways, right? So we have some temperatures in Celsius, we have some temperatures in Fahrenheit, and they're all kind of jumbled together, right? And we don't want to compare temperatures of Celsius to temperatures of Fahrenheit because that would be like comparing apples to oranges. We always want to stick with apples to apples. We want to put everything maybe in an organized way so we have all of the Celsius group together and all of the Fahrenheit group together, right? Does it seem like a reasonable thing to want to do? Well, I think it's a pretty reasonable thing. So I'm going to go ahead and organize our data. And the way to sort data in Google Sheets is you're going to hover your mouse cursor over the starting column of your data, and you're going to left click and hold down, and you're going to drag it all the way over and select all of your data. So I'm going to select all of the columns that have my data in it. And this is the data that I want to sort. And to sort it, I'm going to go to Data, and then click on Data and go down to Sort Range. And when I click on this, it's going to give me this pop-out window. So this pop-out window has this first little checkbox, and it says Data has a header row. So a header row just means that it has this first row telling you what is below it in each column. It's basically saying, hey, keep this row right here where it's at while you're sorting everything below it. So we're going to click that because we have a data header row. We're going to choose what to sort by. So you're going to choose what column to sort. So we could sort temperature column, which is this first one, unit, type, gender, and age. I'm going to want to sort by unit. So sorting by unit will sort out each of these Fahrenheit or Celsius, and you can do it A to Z, meaning Celsius comes before Fahrenheit, or you could do Z to A, meaning Fahrenheit comes before Celsius. So I'm going to click A to Z. I'm going to sort it, and it's going to arrange all of my data such that Celsius comes first, and then after all the Celsius units, you'll have Fahrenheit. So that's how you sort the data. And now I have my data nice and sorted. I have all of the Celsius together. I have all of the Fahrenheit together. Now what we're going to want to do, because we probably want to compare these temperatures to each other. So we're probably going to want to take all of our Celsius data and somehow convert it to Fahrenheit. So I'm going to walk you through how the lab manual says to do it. It says to first take all of your Celsius temperatures, and we're going to select them all. So we're just going to left click and drag down until we have all of our Celsius data in this little blue box. We're going to copy it. We're going to come over here to row G. We're going to paste it there. So now we have a copy of all of our Celsius data. And I'm going to denote that this is a column that's going to be in Celsius. So doing this has 2 advantages to it. It takes your original data and it preserves it in column A. So that way you can always come back to column G, and if you mess something up over here, you can copy your data back over. So it kind of preserves your original data in this column A in case you want to go back to and copy it back over, or in case something happens to this column G. Now we're going to make a column for temperature in Fahrenheit, and it's always good to denote what unit you're using when you're doing this sort of stuff. And we're going to use Google formulas to convert all of these Celsius temperatures to Fahrenheit. Now, if you weren't proficient in spreadsheets, you would have to go each individual temperature, plug it into a calculator, calculate what that Fahrenheit temperature might be. And you'd have to do that 50-ish times. Yeah, you'd have to convert like 50 temperatures. So you'd have to do that calculation over and over and over, and that's not something we really want to do. So instead, we're going to use Google Sheets formula to make this conversion. So does anybody know what the conversion from Celsius to temperature is? If I gave you a temperature in Celsius, would you be able to give me the same temperature in Fahrenheit? Who knows what that conversion is? Someone in chat. 273, that would be from Celsius to Kelvin, right? So if you take your Celsius temperature and add 273 to it, then you'll get it in Kelvin. But we want to put it in Fahrenheit. So Ivy says you take your temperature in Celsius, you multiply it by 9/5, and you add 32 to it. That's exactly correct. So let's go ahead and write this out. We're going to select our cell that we're going to start our calculations in. We're going to let Google Sheets know we're starting in calculations by placing an equal sign. So anytime you put equal sign, it knows, hey, this is going to be a formula. Now we're going to take C in this. If you look in the chat, Ivy put the formula. C is your temperature in Celsius. So I'm going to scroll over here with my mouse, and I'm going to click the temperature in Celsius, and it puts it into that formula for me. It knows, okay, we're looking at cell G2. That's our temperature in Celsius. And we're going to multiply this by 9/5. We're going to multiply by 9 and divide by 5. And once we have that, we're going to add 32 to it. So we make this formula, G2 times 9/5 plus 32. Press enter. And it gives us our temperature in Fahrenheit. So it does that conversion right for us. And now we want to calculate all of these temperatures. So if we hover over this little blue box in this bottom right-hand corner, and we left click and hold down, we can scroll down and it'll make a little dotted outline of all of the calculations it's going to do. And we can scroll down to the last Celsius temperature we have, and it'll automatically calculate. And if you look at any of these cells, you can see like for F5, it's going to take the value in cell G5, and it automatically identifies what cell in G that we want to be calculating. Does that make sense? Okay. Now what we're going to do is we're going to take all of our Fahrenheit temperatures, and we're going to do the same thing we just did with the Celsius, where we're going to left click, hold down, and select all, I think it's something like 150 or 200 temperatures. My computer is really struggling today. Oh, more people have filled it out since last week. So we're going to copy our Fahrenheit temperatures. So I just pressed Control-C. You can always right-click, copy, and come over here and right-click, paste. And now we have a full column of the temperatures that people measured in degrees Fahrenheit. We can now convert those Fahrenheit to Celsius if we wanted to. That's part of this lab, and then you're eventually going to put it into Kelvin. So we have all of our temperatures in Fahrenheit, and we're going to want to show this data in some way. We're going to want to display this data. We're going to want to represent this data somehow. And the way we're going to probably want to do this is with the use of a histogram. So to create a histogram, we're going to do the select the column, insert, chart, and I think it's probably going to automatically give me a histogram. And we can, if it doesn't, we can always just scroll down to histogram and select it manually. So we have our histogram. We can do stuff like go to customize histogram, and this is going to be something you're going to have to do in this lab. We're going to determine what the bucket size is going to be. And the bucket size is just how large of a range of data are we putting in each bar. So if we pick a bucket size of 2, then that means for a single bar, it's going to put all of the temperatures between like 98 degrees Fahrenheit and 100 degrees Fahrenheit. If we select 10, it's going to be all of the temperatures between 90 and 100 get put in this bucket. So that's what bucket size is, and that's how you change it here. You can change the range that we're looking at by clicking horizontal axis. Going down here and picking a minimum value. So let's say I want the minimum value to be like 45. It'll set this left-hand side to be 45, and we can say I want the maximum to be 300. It'll set that maximum to be 300. So that's how you set minimum and maximums, and that's how you change bucket sizes. Now let's look at this data and do a little bit of analysis on it. Can anyone see something that's maybe obviously wrong about what we're looking at?
Some of the Celsius were already in Fahrenheit, just mislabeled. So converting them to Fahrenheit made them like 200 plus.
Yeah, exactly. We have like some 200 degree Fahrenheit temperatures here. We're pretty sure that's not right. I'm fairly certain that no one measured a body temperature of 200 Fahrenheit. So my computer's killing me today. There we go. So we have temperatures like right here, where the temperature is 209 degrees Fahrenheit. That's because they probably mislabeled Celsius instead of Fahrenheit. So what are we going to do with this data point then? Do we keep it? Do we toss it? Do we do something else?
Just replace the 98 and the 209.
Okay, replace the 98 and the 209. There might be an issue with that. That is an option, but what issue might arise from that? Noel says leave it the way it was. Maybe there's an issue with leaving it the way it was too. So the problem with using the 98.8 as the value, you start assuming what the person that gave this data was doing. And here maybe the assumption is pretty obvious, but we shouldn't really assume what's going on here. We shouldn't assume that the person made a mistake. So maybe it's not the best idea to use that 98.8 because it is an assumption that we're making. Leaving it the way it is, we can do that, but the issue becomes our charts doesn't tell us a whole lot. So if we leave it the way it is, we have our chart. There we go. We have our chart, which just tells us almost everybody was in this bin, and there were a few people way out here. So our chart starts to be cluttered with this information that we know is probably incorrect. So if we keep it the way it is, we don't actually get an accurate representation of what it is. So Brandon apparently asks, instead of stating it, so exclude the data. Maybe we want to just delete the data out, and that's perfectly fine to do. We have 230-ish data points. So what is losing one that's obviously wrong? We're pretty certain that this is an incorrect data point. So we can just get rid of it, and we don't really have to worry too much about that particular data point. And we can just move on with our lives, and we can do that with the same data point right here. That's also 200 Fahrenheit. So we can exclude that data. And when we do stuff like that, there we go, Brandon puts an exclamation point, exactly what I want to see. So if we exclude data point, the only thing we really need to do at that point is mention somewhere in our lab notebook, hey, there was data points around 200 degrees Fahrenheit. Pretty sure this was wrong, so we excluded this data. You always want to take note of the data that you're going to exclude. Other reasons you might want to exclude data, I'm going to go ahead and sort my data again. So I'm going to select all of my data and I'm going to sort it. And this time I'm going to sort it a little bit differently. I'm going to go data, sort range. And this time I'm going to sort by that temperature in Fahrenheit column. And you'll see it still says A to Z, but that also means numerically 0 and up. So it'll sort all of these numbers from low to high. And let's see. We have this temperature right here of 93.56. So not quite as outlandishly wrong as that 200 degrees Celsius mark, right? It's still a little bit of an outlier, still a bit worrisome. Is that correct? Or is this a worrisome temperature?
Apparently moderate hypothermia.
Yeah, it's under moderate hypothermia. And I think that if you had a body temperature this low, it is something that is hospitalizable. I don't know what the word would actually be. So maybe this isn't a temperature that we can trust. Maybe the person misread the thermometer or something, but we start getting into that assumption again. And what you guys do with this data point is going to be left up to you and your discretion, because one of the skills that you're going to have to develop as a scientist is deciding when a data point is inconceivably wrong and when it is believable and should be kept. You guys are going to have to make that determination of what to do with this particular point. You know, if the temperature is closer to like 90 or ish Fahrenheit, that'd be more obviously wrong. But you know, you're getting to that gray area of what to do with this thing. And if you do choose to delete it, then you're going to have to make some sort of note about why you chose to do so. It would be dishonest to just delete it and pretend like it never existed. All right. Are there any questions about that? Any thoughts, comments, concerns, statements? All right. So let's talk group roles. So your group roles are going to be one of 4 different roles. And if you're in a group of 5, you're just going to repeat on the last role. So the first role is going to be a leader. And the importance of a leader is that this person is going to be making sure that everyone has an equal amount of tasks to do. So if we look at the lab manual, go down here to part 2. The group leader will be the person to make sure that it is divided up equally amongst people. So, for example, the group leader might say, all right, this person is doing steps 1 through 6 of part A. The next person's going to do 7 through 9 of part A, and so on and so forth. So the leader just makes sure everyone has a job to do. The leader also is going to make sure that communication is happening between everyone in the group. And if an issue with communication comes up, the group leader is going to try and deal with that issue of communication or come contact me about that issue. So the important thing that a group leader needs to be able to do is needs to be able to communicate. That is the skill that's being developed with the group leader role, is communication, as well as a little bit of organization. So group leader needs to be able to communicate. Timekeeper is going to be, it's important that this person's good at like time management, right? And what the timekeeper is going to do is make sure that, you know, if person A is responsible for these first 6 tasks that need to happen before person B does these next few tasks, then the timekeeper is going to make sure that timing lines up, meaning that task A gets done by Saturday, so that task B can happen on Sunday, so that task C can happen on Monday. You're going to see a lot of these sort of series tasks where the next one relies on the first one being done. So that's where the timekeeper comes into play. They make sure that timing matches up so that everything gets done by Wednesday midnight. So someone who's good and organized and good with time management is a good person to suggest for your timekeeper. The recorder, this person is going to be kind of like the last editor of your lab notebook. This person is going to be responsible for making sure your lab notebook has everything that it needs to have in it, as well as make sure like all of the data is there, organized in an understandable way, that all the graphs there are necessary, that all the questions are answered, and that there's some overarching organization for your lab notebook. So the recorder is basically that last editor before the notebook gets submitted to the Blackboard. So your recorder, and then we have the helper role. And the helper is just basically playing the field, making sure that if any slack starts to come up, that helper is the person to, you know, help out. So aside from doing the helpers assigned tasks of like, you know, part A, numbers 1 through 6, if the recorder needs help putting the lab notebook together, the helper's there to help out with that. If someone needs a little bit of help with their specific lab assigned task, the helper's there to help them out as well. So helper's just kind of playing the field, helping out wherever it's needed. If you guys have a group of 5, and I don't know if this class does have any group of 5s, but if you do, then you're going to have 2 of those helper roles. So those are the group roles. Are there any questions about that? All right. If not, I'm going to put you guys in your breakout rooms, and I'm going to ask that you stick around until I pop into your breakout room for the first time. I'm just going to be popping in to make sure that everyone has an assigned role, and that everyone's good to go. And once I give you guys sort of the first little check-in, you're free to head out whenever you feel like your group is ready and has some form of a game plan.